of type integer. But you can combine declaration as well as the installation. How that is done? Data type, array name, size equal to array elements. Okay, here you mentioned that array size is 5, but you are not initialized all 5 elements. First element is okay, 0th index, index 1, index 2, index 3. The last element is not there. Uninitialized value will be initialized to 0. So actually elements are 1, 2, 3, 4, 0, because 0 is not there, but it is put 0 during allocation time. Other way of declaring and initializing in this way. Here we have not mentioned the size, but how size is computed? Number of elements in the array, 1, 2, 3, 4, 5. Here array size is fixed, array elements 5. It is example for dynamic static array. Array size is 5. If you have got only 2 elements, but here size if not mentioned, the size of the array is 2. Here size is computed based on number of elements in this bracket. Okay, now coming to the size, actually how many memory bytes are reserved? Suppose int requires 4 bytes. Size of this array is 10. 10 into 4. 40 memory locations, 40 bytes are reserved for this array. 40 bytes are reserved for this array. Next, can I modify one of the element? Yes, I can. I can. But remember that this number should not be more than the size. So if it is having 5 elements, so index are 0, 1, 2, 3, 4. A of 5 is invalid. That index cannot be given because that is not there in the array. So here A of 2, A is mentioned. It is having size 5, index are 0, 1, 2, 3, 4. You know that array index starts from 0. I can modify the array. So now array content becomes like this: 1, 2, 89, 4, 5, like that. Okay. So the thing that you have to note, index is used. This is called array index. That index should be greater than 0, greater than equal to 0 and less than the size of the array. How do you retrieve while displaying the data, or how do you use that index while printing, while reading the data? For printing, I wanted to see the 4th element. You know that index start from 0. 3 means 4th element in the array. 1, 0th, 1, 2, 3. That is the 4, value 4. This is the one way of accessing. Other way is that this is, okay, star, the container is a plus 3. A plus 3 doesn't mean that the starting address plus 3. No, this is a third. That means this is 0th element from that 3. 0, 1, 2, 3. This is 0th address, 0th element address. For that you have to skip by how many? 3 data items you have to skip. Okay. That content is 4. In this example, A is this one, A plus 0, A plus 1, A plus 2, A plus 3. That value is 4. How do you read? For reading now, we need ampersand. I want to modify the value of third element in the array. A of 0, A of 1, A of 2. A of 0, A of 1, A of 2. By reading this now, I can modify this element. A of 2 means third element. A of 0 means first element. Index 2 means third element. Okay. Now, these things are important for data structure. That is why I'm discussing little detail. I'm adding those in the slide. My array size is 4, but I'm having only 2 elements. Third element is not there, fourth element is not there. Index 0 is there, 1 is there. 2 and 3 are not there. So those are initialized to 0. Those are initialized to 0. I'm having only 2 elements. two more elements are missing, so those are initialized to 0. Now we'll see what are the address and what is the content. So array placeholder name is A, which is the starting address of the array. In the stack area that array is allocated, whose address is 6488756. For me it is difficult to remember. For that I am using the name A. Okay, here afterwards this address is also known with A. Very difficult for me to remember this address. Now this is to retrieve that address. Remember that while printing array it is an unsigned number, so use U. Array address, that address is unsigned, use U. So the first element, 0th element address is 6487568. Okay, the content A of 0, the first element in the array, that is 1. Okay, as it is an integer array, each element requires 4 bytes, so it is skipped by 4 bytes. 8, 9, 10, like that. 68, 69, 70, 71, 72. 68, 69, 70, 71 used by the first element. Next location is 72. 648, 75, 72 is allocated to the next element. Next element is 2. Next element is 2. As I told, unused places are replaced by 0. I want to check that one. Okay. Now remember that this A means starting address. A plus 1. A plus 1. Don't think that it is 6487569. No. It is the next element address. What is the next element? 2. What is the address of that? 72. Okay, A plus 0 means 68. A plus 1, actually A plus 1 into 4. A plus 1 into 4. Why 1 into 4? 4 because it is integer. 1 is index into size. A plus 1 into the size. Okay, in this case ampersand A of 2. What is the address? 0th address, first element, third element. 68, 72, 76. So that can be accessed A of 2. A of 2 ampersand is the address. A of 2 is the content. This is container. This is content. Container address is this one. Content is 0. In the same way, this is container. This is container. This is content. Star for content. Star for content, ampersand for container. Ampersand for container, star for content. In this program, I gave all different options. I can use A of 0 or star. I can use A of 0 to retrieve the data, or star also I can use it. Directly A for printing the address, or ampersand. All these possibilities I gave. Okay, this particular slide is important, that gives you idea how to access array. Okay, coming to this slide, how this is stored internally. Okay, we'll assume that the memory allocated to array A is 2000. Array size is of 10 elements. Array size is of 12 also. Index 0, index 1, 2, 3, like that it goes. Starting address 200. This is the container address. The content is 11. Next element where that is put. As it is integer array, 4 bytes are reserved for this one. Skip 4 bytes. 200 plus 4, 2000 or 204. Their value is assigned. Remember that these are all the index. These are all the address, container. These are all the content, the data. Okay. How do you compute address of 10th element? I want 240. How do you compute it? Starting address 200. The 10th element plus 10 into size of each of the element, that is 4. 200 plus 10 into 4. 200 plus 10 into 4. 10 into 4 is 40. 200 plus 40 is 240. You can see that here also address of A is 200. So that can be done like this. A plus 0, 200. The content can be retrieved with A of 0, that is also correct, or star of A plus 0. A address 200. This is 200 plus 0 into 4, 0. 200 plus 0, 200. What is the content? It is 11. Now we'll go for A plus 2. A plus 2. A is 200. Plus 2 means 2 into 4. 2 into 4 is 8. 200 plus 8, that is 208. The content is 17. A plus 2 means 200 plus 2 into 4. A 200, 2 into 4, 8. 200 plus 8, 208. Container address is 208. The content 17. Content 17. So in general, this formula can be used. How? The base address plus size of the data in case of integer 4, in case of character 1, like that, into index. Whenever you see this kind of thing in your mind, this should be done in this way, should be done. Base address plus size into index. One more program on array. My array is declared of type integer. What is the size of this array? 4 into number of bytes required. Each integer requires 4. 4 into 4 is 16. 16 continuous memory locations are reserved for this A. Am I having the value for A of 0 or 1 like that? No, because not yet done. Initialization not yet done. So garbage values are there in these locations. I'm going to read it. Where I'm going to put it? A of 0. A of 0, whatever the value we input. In my case, I just entered 2. The 2 is put in this location. Okay. How do you access the second element? The other way is ampersand A of 1. Other way is ampersand A of 0, A of 1. So this is also possible. When you use this way, no, ampersand is not required. When you use index, ampersand is required. When you don't use index, ampersand is not required. A plus 1, actual address is that starting address plus 1 into 4. In that location, the value that is entered, value that you input is stored. Say 1. Okay, 1 or 2, anything. Next, same, this I explained in the previous slide. Star A plus 0. The container A plus 0. A, if you assume starting address as 200, 200 plus 0 into 4. 200 plus 0. Its content, the value is that one, like that. Okay. Star content A plus 0 address. The other way is that the same thing is written like this with the index. Whichever the method you are comfortable, you just follow it. I told different method of accessing the array. Okay, because these you should know. For that purpose, I put that in the slide. Now the next topic is two-dimensional array. In the same way, array is declared. The data type, name of the array, size. But here you can see two dimension. Number of columns, number of rows. In case of two dimensions, actually these are stored in the serial format. But how? It can be row major or it can be column major. Now we'll see that. We'll initialize the array. Okay. This is my first row. These are my second row. These are the element in the third row. 1, 2, 3 in the first row. 4, 5, 6 in the second row. 7, 8, 9 in the third row. Okay. 3 rows, 3 columns. I told there are two different ways of storing that in the memory. Actually, there is no separation of column and row. All these are continuously done. But we should know how these data are put. That is the way, column major or row major. In case of row major, first you go on store the data of in that row. I'm taking the first row, 1, 2, 3 are put one after the other. After the completion, once you reach the last column, number of columns here is 3. After reaching to the last column, go to the next row. Next row is 4, 5, 6. At the end of that, just go to the next row, 7, 8, 9. So row major means you are going to allocate the elements row by row. After the completion of a row, go to the next row, row by row. So for that easy understanding, I put colors. Okay, the first row, second row, third row. Other is the column major. First to complete a column, first column 1, 4, 7. After reaching to the last row in that column, go to the next column, 258. After reaching to the last column in that last row, no, go to the next column, 369. 147, 147, 258, 258, 369, 369. This is for our reference. This is how memory is actually allocated in the computer, in the memory. Okay. In the same way, the array can be accessed with the help of index. A of 1 of 2 means the first row, this row, third element, third element. The result of this is 6. A of 1, this is A of 0, this is A of 1, this is A of 2. So we are accessing A of 1, this one. In that which column? 0th column, first column, second column. 0th column, first column, second column. Second column in that row is 6. Same can be accessed with the help of address. Okay, this is a pointer. One row, second row, third row. So A of 1 means the second row, that is index 1. From that row, here, which element? Index 2. A of 0, 1, 2. A of 1, 0, A of 1, 1, A of 1, 2. Actually, both are same. You can access that array with the help of pure index or with the help of asterisk. Okay, we can refer that array in these two different way. As I told, whichever the method is comfortable, you can use it. Okay, same example we'll take how that is internally allocated in terms of memory address. I will be taking starting address of num as 1000. Okay, we'll go for row major. 1, 2, 3, 4 first. 1, 2, 3, 4 first. Then 5, 6, 7, 8. 5, 6, 7, 8. Next row, last row. 9, 10, 11, 12. 9, 10, 11, 12. Starting address is 1000. It is of type integer, 4 bytes. 1000 plus 4. 1004 plus 4. 1008 plus 4. 1012 plus 4, 16. 16 plus 4, 1020. 1020 plus 4, 1024. 1024 plus 4, 8. As you can see, all these elements are serially, continuously done. Continuous memory allocation. Okay, total of these memory locations are result. How? 3 into 4, 12. 3 into 4, 12. Each requires 4 bytes. 12 into 4, total 40 bytes are result. 1, 2, 3, like that. 12 into 4, 48 bytes are result. 3 into 4, 12 elements, each of size 4 bytes. 12 into 4, total 48 bytes are result. Starting from 1000 till 1004, like that. Okay. So the first element address is 1000. The first row address is 1000. Second row address is 1016. Third row address is 1032. First row index 1 is 1004. First row index, first row, like that. Okay. Remember here, this is the starting address of the array. Each row address is here. Okay. So here how the allocation is done? Row wise. One after the next row. First row, second row, third row. In our C programming, index always start from 0. Row 0, column 0. Here. Row 0, column 0. Row 1, row 0, column 1. Column 2, column 3. Row 1, column 0, row 1, column 2, row 1, column 3, row 1, column 3. Row 2, column 0, column 1, column 2, column 3. Okay. Same thing for uh, this one, the other method, the column wise. Okay, here column wise. Here each time one column is considered. As you can see, 159, the first column data. After the completion of that column, go to the next column. Next column data are 2, 6, 10. Then 3, 7, 11, 4, 8, 12. What I want to tell here, data are put in column wise, one after the other column. But the total memory is same. How the memory is calculated? 3 into 4, 12 into 4 is 48. Total bytes are same, but the way in which data are organized may be in the column major or in the row major form. Okay. For your reference, all these are put in another slide. Both are same. A of I can be referenced in this way. The in case of two-dimensional array, one more dimension you have to add it. Okay, just for reference I put that in this slide. So array and the pointer both are same. In this way array elements can be accessed. Okay. The same thing, how address is calculated. From this diagram you can refer it. Can refer it. Okay, we'll take the last one, the string or the character array. I'm having a string str of 6 hello. The last character is null character. Same this is static allocation, this is dynamic allocation hello. The content is same, but this one is using pointer, this is character array. In the same way you can also put in terms of characters, that is inside array. Here size is 1 2 3 4 5. Here size is 1 2 3 4 5 6 null character. Okay, so with this I'll be ending this session. We'll take one more video in the next day with the other topic. Thank you for listening.